So, hello, Amos. Can you still hear me? Are you still here?
Yes, I can hear.
Okay, all right. So we have majority of them are joining in now. So you can go ahead to start the class. Others will join in as the class progress.
Okay, sure.
All
Good
right.
evening, everyone. Let me share my screen. Hello, please can you see?
Yes, I can see your screen.
Okay. All right. So good evening once again. So as you already know, my name is Amos Eidu, and I'm a software engineer located in Ghana. And I have a bachelor's degree in computer science. Yeah, so that's something little about me. So as you can see on the screen, this is how I want today's lesson to go. So I've already given my introduction, so that's it. So we are going to look at what we have for today, and then we're going to look at a system called Strapi, right? And how they've implemented so beautifully the topic that we have for today. That's sorting, pagination, and filtering. And then finally, we are going to look at some code. So that's basically the agenda. So it's going to be fun. So let's get started. So today's topic is sorting, pagination, and filtering, right? And the whole essence of sorting, pagination, and filtering is one to provide very good experience to users using our application, whether a website or a web application, right? And also to make sure that our application is fast, right? Because as you are going to be fetching data from endpoints and stuff like that, the amount of data that you are going to be receiving can be very huge, right? And reducing the amount of data that you fetch at a particular point in time can really improve the user experience and also make your application very fast. And so for sorting, basically what sorting means is that we have some piece of data and then we have some criteria in which we want to order this data upon, right? And a very simple example is when we have numbers. And then we want to order these numbers in ascending order. Right? So we sort these numbers in ascending order, and then we have -1, 5, 7, 9, and 10. Right. So as we'll be working with data from databases, we'll have so for example, let's say we have data of customers using our application. We might want to sort the data based on the names of the customers, or the data based on the IDs of the customers, right? So that's an example of sorting in APIs. And for pagination, for example, if you are working with data which is as large as 10,000, right? And then we want to display that data on our website, it wouldn't make sense to grab all that 10,000 data and then display at once on our website. It's really good to hit the performance of the website, and also it isn't really going to be relevant to the person visiting the website. So in such a situation, you are going to use pagination and just get some portion of the data that it can show to the user at a point in time. And we see that almost always when we use websites, when we search for something on Google, we get the most relevant results on our first page. And then the other pages are paginated. So when it's necessary for us to get more results, then we use the pagination numbers down there to navigate through the other results, right? So that's an example of pagination with sorting. And also when we go to Netflix, right, there are a lot of movies there, but we tend to see the most relevant movies, right? And for other movies that we want to see, then we have to click on the pagination down there to move us to the next page. Right? So that's pagination. And also for filtering, we might want to find some specific data amongst a lot of data, right? And this is where filtering comes in. So I have 10 data which has 10,000 elements, and then I want to find some specific elements in this 10,000 elements data. Then filtering is going to be the way forward in this direction. Yeah, so that's something brief about sorting, pagination, and filtering, right? So next, I want us to go to Strapi. And let me give something little about this. The reason why I want us to look at Strapi is its way of implementing filtering, pagination, and sorting is so beautiful, right? And it's so documented very beautifully that we can learn a lot from how Strapi implements filtering, pagination, and sorting, so that we can, know what to do. So Strapi is a headless CMS, which basically helps us design APIs like very quickly and also to manage content. So when we take Strapi, you can think of WordPress, but not tied to any particular UI. Right? So we can design a very an API very quickly with Strapi, and then hook it up to any kind of front end that we want to hook it up with, whether React, whether Vue.js, whether Angular, which makes Strapi very, very beautiful. So in Strapi's documentation, it documents, it has a field on API parameters, right? And it documents how it does its filtering, right? And also it documents how it does its sorting and pagination. So from this time onwards, I would like us to just go through some of these and then get an idea of how filtering, sorting, and pagination works. So currently, I've already set up a project in Strapi, right? And then it contains 100 products. And it's with these 100 products that we are going to practice filtering, sorting, and pagination with. Please, I hope you are following me so far.
Yes, we are.
Oh, okay. And feel free to ping me in case you have any questions. All right, so we have these elements here, which let's go to the structure of these data. So this data is so they are basically products, right? And the fields are the title of the product, the description of the product, the price of the product, the discount rating, and whatnot. And then there are 100 of such elements. And I pulled this data from this particular data source. So there's it, dummy.json.com/product. So when we visit this particular endpoint, we have all these products here. and then I grab this data, and then I imported them into Strapi, right? So there are various ways of implementing filtering, sorting, and pagination, right? And then the most common one is by using what we call query strings, right? So query strings basically allow us to pass in additional information when we are making a request to an API, right? So an example is when we have a particular endpoint, and then we want to pass in some extra information. So for example, an ID, we can use a query string, which follows the question mark sign. So let's say we want to query this API based on an ID, which is equal to 1, right? So we pass in this particular query string to this endpoint, and then we get our response, right? So in implementing filtering, basically this is probably almost 95% of the time, this is how you are going to find filtering, sorting, and pagination being implemented, right? So looking at this documentation over here, for Strapi, we have a GET request to the API, and then we have the query strings. So for the filtering, it passes a filters parameter to the query string, and then the particular field, and then we have something called an operator and then a value. I'm going to look at what that all those means in a bit, right? So once we pass these query strings to the end to the endpoint, we are going to get our results. So let's look at an example with Postman. Okay, so our API is on this URL. Please, I hope you can see the Postman.
Yes, we can.
Okay. So when we make a request to this particular endpoint, let me make the request and let's see. So this is our response from the endpoint. So you have the data, and then we have all these values. So we have the ID, the title, the description, and whatnot. And as we saw from the Strapi documentation, we can pass a particular filter by using the filters query string and then a property. So let's say I want to find the product whose ID is equal to 1. Then I'm going to pass in this filters query string, specify the ID, and then specify another property which is equal, and then specify the value. So once I make the request, realize that it has filtered this particular data for me, and I do not have any other data in addition to it. Right, so this is a typical example of how filters are implemented in. And very soon, we are going to look at how beautifully this particular query string maps onto JavaScript and a JavaScript object, right? So let's look at another one. So let's say we want to find all the prices that are less than 400. So also, we are going to specify the property, which is price. And then we are going to specify a filter, which is less than or equal to, which is LTE. And then finally, we specify the value, which is 400. So this one also gives us a response. And if we check the prices, all of them are correctly less than or equal to 400. Okay. So there are examples here that we can look at. So this one makes a request to an API with the user's route, and then it specifies the filters with the username and then the filter, which is equal to, and then it specifies the value. Now, if we check here, realize that it maps beautifully to a JavaScript object like this. So you have an object, and in that object, the property that we specified is a property of, it's an attribute of the object. And then the filter is also an attribute of the property, right? So this helps us in passing these filters directly to whatever database that we are using. So for example, regardless of whether we are using MongoDB or we are using an SQL-based database like SQL or MySQL or Postgres, it doesn't matter. Once we get this particular object, then we can easily further make our queries across our databases. So that's a typical example of how filtering is usually implemented in APIs. And it cuts across any kind of API that I'm going to see. Almost always, any API that I'm going to see, this is how filtering is implemented. And it's very simple and very easy to understand. Please, I hope you are following me so far.
Yes, we are.
Okay.
Yes, we are.
Okay. And then next, we have the sorting. And the same thing applies to the filtering. So we pass in the sort query string, and then we pass in the value by which we want to sort by. So if, for example, we want to sort by the prices, then we are going to have the endpoint, and they are going to have the query string sort is equal to price. And then when it comes, the values are going to be sorted by prices. And also we can specify further whether we want it to be sorted by, ascending order or descending order, right? And in that case, we can specify that by adding a colon and then either ASC for ascending or DESC for descending. And then for multiple values, we have sort, and then we index, and then we specify the value, the first value, and then we have the ampersand sign and so on and so forth for the relevant values that we want to sort by. So in case we sort by the first value and then there's a tie, that tie is going to be broken by the second value and so on and so forth. So this is an example that we have over here. So there's an endpoint, and then it's being sorted by the title, and then it's being sorted by the slug also. And if we look at the object, this maps out to, it maps out beautifully to an array, right? So we have the sort property, and then the value is an array, which is the title, and then a slug, right? And then we can test this also in Postman. So now that we've filtered by prices which are less than or equal to 400. Now we want to sort by the prices. So we are going to specify the sort property, and then we are going to give it the value of price. So after making the request, if we check the responses, you realize that 10 is the smallest price over here, followed by 12, followed by 13, 14, and so on and so forth. And if we add the colon and then the descending, realize that it sorts in descending order. So we have 280 being the biggest, we have 120 following it, and so on and so forth, right? And there we have it. To be able to sort results from an endpoint, we can just pass in this query string sort and then pass in the relevant information for the server to process the data and then return it to us. And that's how easy it is to add sorting to whatever endpoints that you are implementing. And then finally, we have pagination. And with the pagination, there are multiple ways of implementing pagination, right? But Strapi allows you to be able to use two of those multiple ways. The first one being pagination by page, and then the second one being pagination by offset. So I'm going to explain what those means. So given our data, we have 100 elements or 100 products in our data, right? So given 100 elements, if you have a page size of 10, 100 divided by 10 is 10. So it means that you have 10 pages, right? So think of a page as a set of elements that make up like the first part of a pagination. So if we have a pagination and then we've numbered them from 1 up to 10, number 1 is the first page, number 2 is the second page, number 3 is the third page, and so on and so forth. Right. So over here, we can pass in the page number that we want, and then the page size. So if our elements are 100, and then we pass in a page size of 10, then it means that it's going to give us the numbers, the elements from number 1 to 10. And if we pass in a page size of 10, and then we pass in a page number of 5, then it's going to give us the elements from number 50 to number 60. Right, so that's how the paging works in that regard. And with offsetting, it's like having an array. An array of elements. So we can say the default offset of this particular array is 0. So if you want to take 5 elements from this array, we are going to start from the offset, which is position 0, and then pick 5 elements. So they are going to be A, B, C, D, and E. If our offset is, for example, 4, and then we are saying that we want to take 5 elements, then we are going to start from E, and then pick elements E, F, G, H, I. So that's the basic idea of offsetting. So in application to pagination, it means that we can specify the start point, which is basically the offset where we want to start from. And then the limit is the number of elements that we want to pick from our database. And then the pagination is going to grab the elements within that range and then give it to us. Yeah, so that's it for the pagination by page and then offset. And then the most popular one that is used is by the offset. So we are going to look at an example of pagination by offset. So let's go back to Postman. So let's say in this particular case, we have a pagination that contains 5 elements each. Then we can specify the pagination parameter and then specify start. So starting from 0 and pagination limit is equal to 5. So when you make this request, you are going to realize that truly the number of elements that we have is 5. So this is our first element with an ID of 4. The second element with an ID of 14. The third with an ID of 47. The fourth with an ID of 61. And then the fifth with an ID of 38. Right. And then we can try another one. So let's take notes. This one's ID is 4, right? And then this one's ID is 14. So let's say we decide to start from 1 instead of 4, from 1 instead of 0, then what are we going to get? So if I change this to 1, then it's going to start from 14. And if it starts from 2, instead of starting from 14, it's going to start at 47. Right. Yes. So this is how typically pagination, sorting, and filtering is implemented with regards to APIs. So that's it for Strapi. Please, does anyone have any question at this point? Okay. So it means I can continue.
Yeah, you can.
Sorry, did someone say something?
No, I said yes, you can continue. If they have questions, they would ask, and I think they can also drop their questions in the chat.
Okay, sure.
All right.
All right. So let's look at some code. So basically, I wouldn't want to implement this with regards to any particular database, whether Postgres or Mongo. Right? So we are going to implement something very, very simple, a tiny subset of what we've seen so far with regards to filtering, pagination, and sorting in Node.js. Right, and then we are going to use the same data that we have imported in Strapi, right? But we are going to use the data as raw JSON, and then just write some JavaScript and see how it goes. Okay. So I've set up a simple Express.js file or project. And let's take a look at our package.json. So basically we have Express, Morgan, and QS, which we might or we might not use. And we have a script file over here. And all this file does is it takes our products.json file and then it passes it, and then it spits out the products that are inside that particular script. So if you run script.js, the output is a JSON output. So that's what this script file does. And then I've saved the results in products2.json. So that's what we'll be using in this particular code example. So in our main.js file, I've set up the basic things that we're going to see in an Express code. Imported Express, imported Morgan for login. And yeah, that's all we have. And then finally, we have our routes, which contains the products with some boilerplate code to make us move a bit faster, right? So let's start the project. So currently, any request that we are going to make to this endpoint is going to give us the JSON data as a response. And let's test that with Postman. So we have our simple server running at on ports, listening on port 3000, and making a request to this particular. Sorry. We need to set up a few things. So we are going to import our route file and then set up an endpoint to products for the product route. Okay, so now making a request to the endpoint returns everything that we need, right? So this one has an ID of 1. And then the very last element has an ID of 100, right? So at the end, we will want to implement some simple form of filtering, some simple form of sorting, and then some simple form of pagination in this our endpoint. So let's start with filtering. So based on what we've seen with Strapi, now that is going to be our point of reference. So you want to implement something as close to how Sharpie implements their filtering as possible, right? And we can look at this typical simple example. So if I want to filter okay. So by passing this as our query string to our endpoint, what it means is that you are going to filter by our price, by the prices that are less than or equal to 400, right? So what this line of code basically does is it does some form of distracting. It grabs the filters object from the query. It grabs the sort object from the query, and then it grabs the pagination object from the query, right? So currently we didn't pass any filters to the query. So this console.log line is going to spit out undefined, and that's what we see over here. So let's make those changes. Now we can see the console.log filters gives us price, and then it gives us a property less than or equal to, and then it gives us 400, right? So now based on this object, we can now write some code to do the filtering. So in JavaScript, you have a function called filter. And then what it does, it tests a particular array against some predicates, and then it returns a new array for all those elements that passes that particular predicate. So in this particular situation, we want to grab every element in our data and then check to see whether the price is indeed less than or equal to 400. So we can have our product. And then check and see whether product dot price Okay, so basically what I did is I'm looping through all the elements in our data array, right? And then the filters that we passed to our endpoint is that for price, right? And then it has a property which is less than or equal to, and then it has a value of 400. So we are checking whether the product dot price is less than or equal to filters dot, sorry, price. So we can test this on Postman and see whether we've correctly filtered our endpoint. So we have an error, and let's debug to see. Okay, so now we have our results. So if we check the prices, you are going to realize that the prices are indeed less than or equal to 400. Yes, so that's roughly how filtering would be working. But typically, you're not going to be doing stuff like this because most databases or every database engine out there that are going to use has like its own ways of filtering data. All you have to do is know how the database accepts those filters and then pass those filters accordingly. So all you have to do is use a particular library that passes a request. So we are using Express.js, and Express.js out of the box passes query strings for us. But if you are not using Express.js, then you might have to use an external library. And then a very popular one is called QS. Let me show it to you guys in a bit. So this library is QS, and you can pass a query string to this particular library, and then it creates an object for you, right? But if you are using Express.js, then you don't need to use a library like this because Express.js is going to do it all for you. So after you are able to grab your object from this particular query string, then it's now up to you for you to pass this object to your whatever database that you are using and then return the results to your user. So that's it for the filtering, right? And let's take a look at how we are going to implement the sorting also. So let's say we want to sort by prices. So when we console.log sort, it's going to give us an idea of how the object is. So if you look here, it has given us price, which is giving us an idea of which particular field that you're supposed to sort our resulting data. So after filtering, we would typically want to apply a sort to our new data. And then JavaScript allows us to do this also out of the box. So after filtering our data, then we sort our data. Over here, we are going to assume that you are always sorting in ascending order. So you are going to pass in an anonymous function, which specifies how exactly we are going to sort this particular data. And then we return the results as JSON. So when we check Postman, hopefully we should have the filtered data and then the sorted data as well. And let's see. So over here, we have our price 280, price 13, which means that the sorting didn't work. So let's try and debug and see why it didn't work. Okay. So basically, sort is specifying which particular field we are supposed to sort the products by, right? And then this product A is going to be a leftmost product, and then product B is going to be the rightmost product. So what was missing out is specifying which particular field that we are sorting products by. So by passing sort to product A and passing sort to product B, then it should be able to sort by whatever value that we specified in sort, right? Which over here is price. So let's restart our server and then see. So looking at it, now we have our data filtered by prices which are less than or equal to 400 and also sorted by prices in ascending order. So the first price over here is 10. The second price over here is 12. The price there is 13. The price there is 13, and so on and so forth. So we've been able to successfully implement filtering and then sorting in our API. So if you want to sort in descending order, you can just change the order and then go back to Postman and see whether we have whatever, we have the correct result. And just like the results that Strapi gave us, so checking here, so the first element's ID was 4 with a price of 280. The second element's ID was 14 with a price of 120. Our endpoint also produces the same result, an ID of 4, a price of 280, an ID of 14, and then a price of 120. Right. So that's it for the pagination. Sorry, that's it for the filtering and then the sorting. And then finally, we would want to perform some form of pagination on our data, right? And because our JSON data is in the form of an array, it makes it even easier. All you have to do is take a slice of the array given what has been specified in our query parameters. So just like we console log the sort, let's console log pagination and then pass in some parameters and see what we have. So we can specify the starting point to be, for example, 0. And then we specify the limit to be, let's say, 10. So we make this request, and then we go back to our console and see what was logged. We have the pagination objects being printed out. And it's very simple. It has a start property, which is 0, and then it has a limit property, which is 10. And basically, all we have to do is take a subset of that particular array, using start as our starting index and using limit as our ending index. So you have a pagination dot start, and then our pagination dot limit. That's one. So let's restart our server and make a request and see whether we are going to have the data paginated finally. So it's not paginated. So we can also go back and debug and see why it didn't paginate.
You can check if you restart the server.
Oh, okay. I think I did. Let me. Probably JavaScript is misinterpreting the values. So let me see whether passing it as integers would work. Yeah, it did. Because this is a string and then this is a number, right? So it's going to perform a concatenation and it's going to be equal to 101 instead of 11. So I have to pass it as a string, as an int before adding the one, and it's going to fix it. It's because of type coercion, JavaScript. Yes. Okay. Yes. And now we have 10 elements. And if we compare that to what Strapi gave us. The first element ID is 4, and then the last element ID is 20. And here is 20. So I think the final thing I'll have to do is remove the +1 over here, I guess. Yes. Yeah, so that's it for the implementation for filtering, sorting, and pagination. So I made us do it like this so that we a step further to like writing like some code to get an understanding of how things are working under the hood. But on a normal basis, you are going to be relying on your own databases algorithms to filter, sort, and then do the paginations for you. All you need to do is, like I said, pass this particular query string. So for example, this long string that we have over here, get a library that is able to pass this particular string into a beautiful JavaScript object. Now grab that object and then pre-process that object if there's the need to, and then pass that object to your database. And then the database is going to do the rest of the work for you. So this brings us to the end of our lesson. So if anyone has any question at this point, you can ask me.
All right, so thank you so much, Amos. It was a lovely session. So guys, if you have any questions, please go ahead to ask your questions. Amos is open to answering them. Or if you understood, just let us know you understood by dropping a message in the chat session. So guys, you have, okay, let's say your question probably within the next 2 minutes. If not,
okay, and
thank you, Amos.
Yeah, sure. And I'm available on LinkedIn to Amos Edu, so you can always leave me a message. And
all right, so I would drop your LinkedIn handle here.
Yeah.
So that means everyone understood this session. That's nice. So, all right, guys, I just dropped Amos' LinkedIn handle, so you can follow him on, connect with him on LinkedIn, and you can also send a message to him on LinkedIn. So that means there's no question from anyone here. So thank you so much, Amos, for coming on the call. Thank you for your time. We really appreciate it.
Sure. My pleasure.
All right. So that being said, good night, good morning, good afternoon, everyone. Thank you all. Bye, guys.
All right. Bye.
All right.